All right, guys, we're going to continue on here with absolute value equations and inequalities. The last video you did was equations. Today we're going to be focusing on the inequalities. But before we jump into that, I didn't know some of you, this guy's starting to get outdated, but Bruno Mars, kind of a big fan. But this guy's not a fan of anything. I love it. Okay, so here it says key concept: solving absolute value inequalities. To solve an inequality in the form of the absolute value of A is less than B, where A is a variable expression and B is greater than 0. Solve the compound inequality such as this. So B's got to be a positive value, okay? And then it's a less than sign. It's going to look like this. All right, make sure that you have paused and copied this down because it's going to be very important and it's hard to remember, so you'll want to have these notes for your checkpoint. So you should see this graph, and when you think of compound inequalities, you should think of that one as the word and you've seen them look like that. This right here, if it is a positive value, B's positive, and it's a greater than, then these set themselves up like an OR inequality. Okay, and the similar rules for these. So let's go ahead and see how these play out. So here it says solve W minus 13 is less than or equal to 34, and then graph the solutions. So for this, I would take 34 and I would make it negative 34 is less than or equal to W minus 13 is less than or equal to positive 34. So there's my compound inequality that I'm going to solve. You've already seen problems like this. The way this works here is I would add 13, but remember I have 3 things that I have to keep balanced here, so I need to add 13 to all of these values. This is negative, I believe, 21, negative 21. Less than or equal to W is less than or equal to, let's see, that would be 47. Okay, so right there is the solution to this. And then the way you would graph this is make your graph. I would have negative 21 on one side, maybe a 0, and then 47. It is closed circles. And then I'm graphing what's in the middle. So think about what this solution means here. This is saying that all the numbers that are inside here will make this a true statement. So let's go ahead and try a couple of them. Let's try 0 since that's the easiest. So if I put in 0 right here, 0 minus 13 is negative 13, but the absolute value of negative 13 is positive 13, which is less than or equal to 34. I could put in 2. Okay, so 2 minus 13 is negative 11. Absolute value is still less than or equal to 34. Let's try a number that's outside of the range, though, and see what happens. So what if we did something like negative 22? So negative 22 minus 13 is negative 35, but because it's an absolute value, it is positive 35. And positive 35 is not less than or equal to 34. The same could be said if I went up here to 50. 50 minus 13 would be, let's see, 47. 47 is not less than or equal to 34. So you could kind of mess around with these different numbers and plug values in here. But what this represents is any number that's inside here will make this a true statement. This has multiple solutions. It's best represented by this graph or this inequality. So here's one for you to try. Go ahead and pause and give that a go. All right, so here is the solution to this. Hopefully you got the same thing. If not, go back and find your mistake. All right, let's take a look at this other scenario, and this is when you have a greater than or equal to. Now, if you recall, you go back to that chart that I had you copy down at the beginning of the video. This tells you that you are making 2 different inequalities. So this first one I just write as it is. Okay, so I have 8n is greater than or equal to 24. The other one, I have to switch it. So I have 8n is greater than or equal to, whoops, not greater than or equal to. I need to pay attention to what I'm doing here. it is less than or equal to negative 24. All right, so there's my OR, and I go through and I solve these two things. So I divide by 8, divide by 8. N is greater than or equal to 3. Over here, divide by 8, divide by 8. N is less than or equal to negative 3. All right, so it says to graph the solutions. So I'd have 3, 0, negative 3. And this one is greater than or equal to. And then I put in this one, less than or equal to. And that's how that graphs. And just like that other one, we could plug in values that are on this graph to see if it works. If I put in 0, 0 should not work. Well, 0 times 8 is 0, and 0 is not greater than 24. If I put in negative 4, well, negative 4 times 8 is negative 32, but because it's absolute value, it becomes positive. And positive 32 is greater than 24, all right? And the same could be said for positive 4 in there. So, I mean, you can mess around with numbers and just see how that works, but this graph represents all of the numbers that will make this a true statement. There's just this little set of numbers inside here that will not make it true. So here's one for you to try. Go ahead and take a moment, pause the video right now, and try this. So here's hopefully what you got. When you go to graph this, negative 9/2 is the same as negative 4.5. So that's the way this graphs over here. And then 1/2 between the 0 and the 1. And that graphs over here. So hopefully you took good notes on this. You'll definitely want to have good notes for this one when you do your checkpoint, because it's kind of easy to forget, you know, when it's less than or equal to or greater than or equal to, what are you doing? Are you doing an AND inequality or an OR inequality? And so having these notes in front of you is definitely going to be helpful. So kudos to you for writing them down. And that is it for this particular lesson. So I will see you in class.